इंट्रो एनेबल करो. मैं बोल दिया कब कर दिया. Welcome to IMS GATE Academy. I hope you are doing great. And remember, my dear students, as I told you, in the GATE preparation, geotechnical subject plays a very important role. In geotechnical, we have two parts. One is the soil mechanics part and the other one is the foundation part. Today, I am here to discuss the most expected questions on the topic properties of soil. So I would like to discuss the most important topic. This is a chapter and the topic we are going to discuss is the properties of soil. Now my dear students, if I talk about the properties of soil, the basic question everyone will ask me is, everyone usually want to ask me, how do you represent a soil? Sir, how do you represent a soil? So for this, my dear students, I would like to tell you the basic things. Okay. Now see students, if I have taken a soil sample, here, 1 second, Shweta. If I have taken a soil sample, suppose, if I consider this as a soil sample, in the soil sample, we might have soil particles. Okay. In the soil particles, there might be, in the voids, there can be what, sir? There can be air or water. So, my dear students, if I talk about this is taken as air, volume of air. Here it is represented as volume of water. Here we represent this as volume of solids. My dear students, if I take a soil sample, in that soil sample you will have soil particles and in the voids there can be air or water. So I have represented here, this is air and this is water and this is solids. And remember my dear students, when I am explaining the most important concepts, I feel that you have some basic idea about the geotechnical. If you want to know about the basics, then you have to go to the foundation course. I hope that you know the basics and I am more concentrating on the repetitive topics in GATE exam. If I see some topic which is coming frequently after every 2 years, that questions will be discussed in the most expected concept. So here if you remember, this is considered as volume of air, this is volume of water and this is volume of solids. And this, whatever we have here, this is the volume of voids. So from this diagram, if you represent total volume is represented as volume of voids plus volume of solids. And my dear students, in volume of voids, we have two things. One is air and other one is water. So volume of air plus volume of solids. So how many constituents are there here? 1, 2 and 3. So there can be a question, how do you represent a soil? So soil can be represented as three-phase system. So my dear students, please write down this point. Soil can be represented as three-phase system. soil can be represented as three-phase system. Now students, you might be asking me whether the soil can be represented in two-phase. I would say yes. I would say yes. Why? Because see students, if I talk about fully dry soil, or if I talk about fully saturated soil, if I talk about the fully dry soil or if I talk about the fully saturated soil, let us understand what do you mean by fully dry soil. Fully dry means there is no water. The voids are completely filled with air. So in this case, my dear students, in fully dry soil, volume of water will be 0. And here volume of voids will be equal to volume of air. And remember, in fully saturated, suppose if the soil is completely immersed in a canal or a river or any water body, the soil is completely saturated. Here the voids are completely filled with water. Hence, the volume of air will be 0. And here, my dear students, volume of voids will be equal to volume of water. So, if we represent the total volume, either in fully dry soil, you will represent as volume of air plus volume of solids. If you represent in fully saturated, volume of water plus volume of solids. So, my dear students, the final conclusion here is soil can be represented as three-phase system and two-phase system. Soil can be represented as three-phase system and two-phase system. So the conclusion, how do you represent a soil? The basic agenda is soil can be represented as three-phase system and two-phase system. Now here I have a small question for you. Sir, you have explained me in fully dry soil and fully saturated soil, it is two-phase. Suppose if I take fully dry soil or fully saturated soil, it is a two-phase system. Am I correct or wrong? But when it will be represented as three-phase system. So intentionally I have not written that. The concept here is in partially saturated soils. If you consider, my dear students, partially saturated soils. In these soils, my dear students, the voids are filled with both air and water. A soil which contains both air and water is nothing but the partially saturated soils. I hope you are clear with this concept. How do we represent a soil? Now let us understand the important properties of soil. See here, why do you want to understand the important properties of the soil? Suppose, my dear students, practically whatever the load which is falling on the slab, it will be transferred to the beam and it will be transferred to the column and then to the foundation. So the entire soil is going to take the entire load. So if you see practically the Leaning Tower of Pisa, why it has leaned? The reason is consolidation. So to understand the bearing capacity, we should have an idea on the properties of soil. If you have an idea on the properties of soil, you will get idea how to classify the soil. It is not like suppose if you are into soil classification, then you can clearly classify whether it is fine grain, coarse grain, or clay or silt. But here, my dear students, using the properties of soil topic, what you can get is you will have an idea on the bearing capacity, or you will have an idea whether the soil is loose or whether the soil is dense. So, my dear students, now we have a concept called void ratio. It is represented by E. Void ratio is represented by a concept called E. Here, my dear students, E can be written as volume of voids upon volume of solids. E can be written as what? Volume of voids upon volume of solids. Now see students, I will give you a simple question. Here they can give you volume of air and they can give you volume of water. And they can ask you, this can be given data and they can ask you void ratio. I'm just giving you these kind of questions will be solved in the most expected questions. Suppose here, my dear students, volume of air is given as 1/3 of total volume and volume of water is given as 1/6 of total volume. If you don't know that volume of air plus volume of water is volume of voids, you should know when you add these two, you'll get volume of voids. And if you remove from total volume, volume of voids, you'll get volume of solids. So you should have an idea how the problem can be asked also. So here void ratio is volume of voids by volume of solids. And remember, my dear students, the range of void ratio, is always greater than 0. Now see students, I will give you a small example. If you talk about natural numbers, you will tell that it is 1 to infinity. If you talk about whole numbers, 0 to infinity. If you talk about integers, minus infinity to infinity. Similarly, the range of void ratio should also be known. Now, my dear students, when I take a soil sample, you cannot expect any soil without voids. If you take a soil sample, means it will have some voids. But numerically, if you put volume of voids is equal to 0, but practically it is not possible. Numerically, you can put volume of voids is equal to 0 and void ratio is 0. It is not at all possible because practically we cannot expect any soil without voids. Now, my dear students, when it can be greater than 1. Suppose if you have considered a soil in a water canal, or if you consider a soil in river, the volume of water will be more than the volume of the soil particles. In that case also, or you can say volume of voids is greater than volume of solids, then also the void ratio can be greater than 1. So this is how you have to understand the range of the void ratio is always greater than 0. If you are looking for the competitive exams, either it is state level or IES prelims, these kind of questions can also be asked. Now, my dear students, the void ratio of fine-grained is always greater than the void ratio of coarse-grained. Sorry. The void ratio of fine-grained is always greater than the void ratio of coarse-grained. See students, the basic agenda here, why the void ratio of fine-grained is very more when compared to coarse-grained. I have given you a beautiful example in the previous sessions also. Like if you take 1 kg of rice, if the rice is made into powder for making a dosa or anything, the rice powder will have more volume than the rice. If you consider rice as coarse-grained and the fine powder as, or the dosa powder as fine-grained, why fine-grained is having more void ratio is, please understand that in coarse-grained, the size of the void is more. But in fine-grained, my dear students, you should understand that in fine-grained, the number of voids will be more. The size will be less, but the number of voids will be more. When you add all the voids, definitely the volume of the voids in fine-grained will be more than the volume of voids in fine-grained will be more than the volume of voids in coarse-grained. Clear? Good evening, Sujna. Good evening. Now let me explain you, there is another concept called porosity. Now see students, why do you want to understand void ratio means? You are trying to understand that how much voids are there with respect to the solids volume. But when I talk about porosity, it is defined as the ratio of volume of voids upon total volume. Volume of voids upon total volume is known as porosity. Agree, my dear students? Now, here I have a question for you. See students, you can write total volume is equal to what? Volume of voids plus volume of solids. Now, my dear students, if I have taken volume of solids constant, then this can be written as 1 plus VV upon Vs. As you know already, VV upon Vs, E is equal to VV upon Vs. So, my dear students, you can write total volume is equal to Vs into 1 plus E. And this derivation will help you. This formula will be very simple, But in problem solving, this equation will help you. Now here, if I substitute in place of total volume Vs into 1 plus E, again this Vv by Vs is what, sir? Vv by Vs is nothing but E. So N can also be written as E upon 1 plus E. Remember, my dear students, whatever things which I am keeping in box, they are very important when you do the problems. So here, what will be the range of porosity? Anyone? Can you tell me quickly? Numerator is less than denominator. Here the numerator is less than denominator. So obviously it will be less than 1. Am I correct or wrong, my dear students? So if you talk about the range of porosity, if I talk about the range of porosity, the range of the porosity will be equal to 0, n less than 1. So this is the range for porosity. Now, my dear students, I will explain you one important thing. Sir, you are telling about void ratio. Void ratio is comparing with respect to the solids volume. When you talk about porosity, you are comparing with the total volume. So what is the actual difference between comparing the total volume and the solids volume? What is the exact difference? If you ask me, I have a simple answer for you. My dear students, in void ratio, only the numerator part will vary. But in porosity, both terms, here also you have Vv, and if you write bottom part also, Vv plus Vs. Please, I will repeat this again. If you see here, numerator varies and denominator also varies. So it is very difficult to handle porosity. But in void ratio, only numerator varies. Why? Remember, my dear students, for any given soil, always the volume of the solids and weight of solids is constant. This statement will help you to solve some important gate questions also. For a given soil, please write down this note, my dear students. For a given soil, volume of solids and weight of solids is constant. For a given soil, volume of solids and weight of solids is constant. Then when I tell you for a given soil, weight of soil and volume of solids are constant, then what is going to vary? It is very simple. Voids are going to vary. If you do compaction, the voids of air will be reduced. If you do rolling, if you squeeze the water from the voids, then consolidation will happen. Then water can come out, then consolidation will happen. If you remove both air and water, then it is compressibility. So, my dear students, the final point I would like to tell you is only the volume of the voids vary, but always the volume of the solids and weight of solids is constant. I hope this statement is clear for you. Now, let me go into the concept of air content. See here, when I talk about air content, sir, the name itself, air content. So how much air is present? So if you see in a soil, I told you in a soil we have soil particles, and in the voids we can be having air or water. There can be air or water, right? Now say students, how much content of or volume of air is present in void's volume? That is nothing but air content. And remember, my dear students, if they ask you in percentage, if they ask you the value of the air content in percentage, just multiply with 100. I hope you are clear. Now see students, if you consider the range of air content, if you consider, the range of air content is 0 less than or equal to air content less than or equal to 1. If you observe here, my dear students, I have used equal to symbol. Okay, why it is equal can be used? It is simple. My dear students, if you consider fully dry soil, if I consider fully dry soil, In fully dry soil, as I told you, voids are completely filled with air. So here volume of air will be equal to volume of voids. But if you consider fully saturated soils, if I consider fully saturated soils, volume of water will be equal to volume of voids. Okay, in this case, fully saturated volume of air will be 0. So hence, air content will be 0. In fully dry soil, air content will be equal to 1. Okay, so that is the reason it can be equal to 0 or it can be equal to 1. Then how it can stay between 0 to 1? It is simple. Actually, if you take this as a set, this is volume of voids, and here you have volume of air and water. So volume of air is a subset of voids. So it can be never greater than volume of voids. It can be equal to volume of voids, but it can be never greater than the volume of voids. That is the reason it is between 0 to 1. Suppose if I talk about here the degree of saturation. If you talk about degree of saturation, SR, we represent degree of saturation as what? SR. So air content is finding the volume of water in the voids content. Similarly here when I talk about degree of saturation, what is the amount of water present in voids, or what is the volume of water present in the volume of voids? That is nothing but degree of saturation. Here it is vice versa. Suppose in fully dry soil, degree of saturation will be equal to 0. And in fully saturated soil, degree of saturation will be equal to 1. As I told you, volume of water will never be greater than the volume of voids. So here you can write 0 less than or equal to SR less than or equal to 1. So this is the equation for 0 less than or equal to SR less than or equal to 1. I hope this is clear for you. Now, my dear students, we have another definition, another small equation. Air content plus degree of saturation is always equal to 1. Air content plus degree of saturation is always equal to 1. Here if you see, what is air content? Air content is nothing but volume of air upon volume of voids. Similarly, if I talk about degree of saturation, it is volume of water upon volume of voids. So when I write here air content plus degree of saturation, when I write here air content plus degree of saturation, it can be written as VA upon VB plus VW upon VV. So here, my dear students, I can take the LCM as VV and you can write it as VA plus VW. And remember, my dear students, what do you mean by VA plus VW? This is equal to VV. So VV by VV is equal to 1. So here, my dear students, air content plus degree of saturation is always equal to 1. Okay? Suppose see student, I'll give you a small example here, how the question can be asked. The example problem. Usually I'll be taking questions in the concept series. Sorry, most expected question, but still to have an idea. If suppose there was a question given like this. If air occupies 1/6 of total volume, if air occupies 1/6 of total volume and water occupies 1/3 of total volume, calculate the void ratio. Calculate the void ratio. Calculate the void ratio. They can ask you this. Okay. Now see here the formula. Whenever the approach to solve the problem, see the concept here. You know the formula of E is equal to what? Volume of voids upon volume of solids. And you know volume of voids is equal to what? Volume of air plus volume of water is equal to volume of voids. So in the problem, it was clearly given as volume of air is equal to V by 6 and VW is V by 3. So volume of voids will be equal to V by 2. And you know volume of solids is equal to total volume minus volume of voids. So this can be written as V minus V by 2. So this will be equal to V by 2. So here if they ask you void ratio is equal to E is equal to VV by Vs. That is equal to V by 2 upon V by 2. That is equal to, the answer is 1. So here the void ratio answer is 1. I hope you are clear with the problem. Now see students, we also have another concept in this. Another one is the percentage of air voids. We have the next concept here is the percentage of air voids. Now you have a question for me. Sir, you have already discussed air content. Then what is the purpose of learning air void, percentage of air voids? When I talk about void ratio, it is always going to compare the voids with respect to the solids. In air content, volume of air is compared with the voids volume only. Here if you consider the percentage of air voids, Na will be taken as volume of air upon total volume. Here when I talk about the percentage of air voids, it is defined as the ratio of volume of the air to the total volume. And remember here my dear students, you can solve this equation. If I substitute volume of air upon total volume, I will multiply with volume of voids and I will divide with volume of voids so that the equation will not affect. Now see students, if I have taken what is volume of air upon volume of voids and what do you mean by volume of voids upon total volume. Here see students, the percentage of air voids can be written as porosity into air content. So these formulas are very important, and remember my dear students, from properties of soil, definitely in GATE exam, there are very high chance of getting a question. Either it can be 1 mark or it can be 2 marks. So here the percentage of air voids is porosity into air content. Similarly, if I talk about the range of the percentage of air voids, if I talk about the percentage of rain voids here, if I talk about fully dry state, air content will be equal to 1. And if I talk about fully saturated state, air content will be equal to 0. So just substitute these values in the equation and definitely you will have the range. So the range of Na will be equal to 0 less than Na less than or equal to N. My dear students, some people will ask me, sir, why you have written 0 less than Na less than or equal to N? Why can't it be written as 1? 1 you can write, it is absolutely correct. But the intention of writing N is the percentage of air voids will never be greater than the porosity. It will never be greater than the porosity because the volume of air is a subset of the total volume. So that's how the range of the percentage of air voids is 0 Na less than or equal to N. Now let us go to the whatever the important formulas which we have discussed until now. I'll write in one slide. Okay. Now the important formulas which we have discussed until now. So here if you talk about the important formulas, the first formula is void ratio is equal to volume of voids upon volume of solids. And you can also write that N is equal to volume, porosity is equal to volume of voids upon total volume. And the relation between porosity and void ratio is E upon 1 plus E. And you also know air content is equal to volume of air upon volume of voids. And you can write air content plus degree of saturation is equal to 1. And degree of saturation is equal to volume of water upon volume of voids, and percentage of air voids, Na is equal to N into AC. So these are the actual important formulas with the basics. Now let us understand what do you mean by water content. What do you mean by water? What do you mean by water content? Now see students, what do you mean by water content here? Sir, how much weight? Sir, if Amit Goyal, very good evening, very good evening. Sir, if I talk about the water content, until now, we are talking about the voids with respect to the solids. But here, water content is compared with respect to the weights. Until now, we are talking about the volume only. So here, water content is defined as the weight of water. Water content is defined as the weight of water to the weight of solids. Sir, this question can also be arised in your doubt, in your mind, sorry. What is the doubt you can arise in your mind is, sir, if you are talking about degree of saturation, it is volume of water by volume of voids. If you talk about water content, it is the weight of water upon weight of solids. And remember, my dear students, the range of water content, is always greater than or equal to 0. What is the range of the water content? The range of the water content is always greater than or equal to 0. Why it is always greater than or equal to 0? First, let me explain you when it is 0. If you talk, it is a fully dry soil. When it is a dry soil, weight of water is 0. In a dry state, the weight of water is 0, hence water content is 0. But my dear students, if you take lake or if you take a river, weight of water will be more when compared to the weight of solids. In that case, water content can be greater than or equal to 0. If you talk about void ratio, if here water is 0, there can be air. But that is the reason in void ratio I told you cannot be equal to 0. Here it can be equal to 0 because in fully dry state or in deserts, you cannot expect any water content. In that case, the water content can be equal to 0. Now see students, we have different methods. Sir, we have various methods. Let me tell you the best methods to determine the water content. One is the oven drying method. And the next one we have is the calcium carbide method. One is what, my dear students? One is the oven drying method and other one is the calcium carbide method. Now here, what do you mean by oven drying method? Remember, there can be a GATE question also asked. Which is the most accurate method to determine the water content? The most accurate method to determine the water content is oven drying method. Similarly, here, what is the quickest method to determine the water content is calcium carbide method. So let us understand what is actually oven drying method. What is actually oven drying method? When I talk about the oven drying method, here, if I have taken a soil sample, if I assume this as total weight of sample, W is nothing but the weight of sample. And this weight of sample is kept in a oven. Here we have kept the soil in a oven. And here, my dear students, we are maintaining a temperature of 105 to 110 degrees centigrade for a duration of 24 hours. Okay. Now here the question will come. Sir, why can't it be 100 degrees or 200? Actually, if the temperature is more than 100 only, the boiling point is nothing but 100 degrees. That is the reason we have maintained 105. And if the soil is overheated, the soil will lose its nature. That is the reason we are not allowing the soil to heat for higher temperatures. Even though it is taking more time, we are allowing for more time. We are not increasing the temperature because the soil loses its nature. Now, after 24 hours, if you remove the soil, whatever the weight, what is the state of the soil now? It is nothing but now the dry soil, which does not have any water in it. So if you talk here, water content is defined as weight of water upon weight of solids. So weight of water can be written as total weight minus dry weight. And weight of solids is nothing but the dry weight. So water content can be written as, from this formula, W minus WD upon WT. And remember, my dear students, in case of organic soils, or if a soil is containing gypsum, in case of organic soils or gypsum, now the important point I would like to tell you here is the temperature cannot be more than 60 degrees. And here the temperature cannot be more than 80 degrees. Here the temperature cannot be more than 80 degrees. So there are some, because of the chemical reactions, we are maintaining these temperatures in case of organic or gypsum. I hope you are clear with the concept of the oven drying method. Now see students, we also have a method called calcium carbide method. Why calcium carbide method came into picture, I'll tell you. It is simply, if you talk about oven drying method, you say that it is accurate. You can say this one is the most accurate. Totally agree. But the student, if he has visited, the student will ask me, sir, I don't have patience to wait for 24 hours. I want the results immediately. Because the disadvantage is here you are waiting 24 hours. You want the fastest method. So here if I talk about the fastest method, what is the fastest method we have is the fastest method you have is the calcium carbide method. So why we are going with the calcium carbide? Sir, we have another methods like sand bath method, radiation balance method and all. But still, pycnometer method. But I will be concentrating on these two methods. One is the most accurate method and other one is the fastest method. So here what happens is, when calcium carbide reacts with water, it forms calcium hydroxide. If you want to balance the equation also, we can balance C2H2. So here you can balance it with 2. Actually we should write here, as there is no space I have written. So based on the amount of the acetylene gas, there will be a pressure meter setup. What is C2H2? This is one of the objective question and important question. Based on amount of acetylene gas, water content is estimated. And how this water content is estimated is, they will place a pressure meter. Based on that, the water content will be estimated. I hope this is clear. Okay. So here what I would like to tell you is, when I talk about the calcium carbide method, oven drying is the most accurate method. Even though it is the most accurate method, I am looking for the fastest method. Hence, when you are looking about the fastest method, calcium carbide is the method. And how do you estimate water content is based on the acetylene gas. You will have a pressure meter inserted. Based on the pressure, we have tables. Based on that, the gas released will be estimating the water content. Now let me explain you the unit weights. So when I talk about the unit weights of soil, the first one we have to discuss is the bulk unit weight. Or they also call this bulk unit weight as unit weight of soil. So what do you mean by bulk unit weight of soil? What do you mean by bulk unit weight of soil is, it is nothing but gamma. Gamma is equal to total weight of soil upon total volume. And here please understand that total weight can be written as weight of air plus weight of water plus weight of solids. But the weight of air is negligible. Hence, total weight will always written as weight of water plus weight of solids. Students, are you following? Students, still you might have so many queries. Sir, is it the right time to start GATE exam? Definitely it is the right time, but you should have a clear vision. What is your target? Whether I can reach a single digit number, then definitely it is very difficult if you start preparing now. But if you want to achieve some 1000 rank or 500 rank, definitely you will have high chances. If you are very smart, if you have already taken some preparation, then if you attend the most expected concepts or most expected questions, it is a kind of revision and where you require the extra attention. Now see students, if I talk about total weight is equal to weight of water plus weight of solids. And here total volume is equal to what? Volume of air plus volume of water plus volume of solids. So here this is what do you mean by bulk unit weight. Similarly, my dear students, we should also, there is another unit weight called saturated unit weight. Sir, actually to be in the precise way, saturated weight is not a new weight. Actually it is a bulk unit weight, but the state of the soil will change. Based on the state of the soil, the bulk unit weight will be considered as saturated unit weight. When the voids are completely filled with water, that bulk weight is known as saturated unit weight. So here gamma sat will be considered as weight of water plus weight of solids upon total volume. And again I am telling you, my dear students, sir, people will ask me, sir, what is the difference between saturated unit weight and bulk unit weight? The logic is simple. If you see here in the total volume in saturated unit weight, you will write it as volume of water plus volume of solids. Here the volume of air will be 0. But remember, in bulk unit weight, the volume of air will be, the volume of air is there. So my dear students, if you compare both the unit weights, which is the unit weight which is higher, tell me. Sir, I am comparing saturated unit weight and bulk unit weight. Which unit weight will be the highest value? Can anyone comment in the comment box? It is simple, my dear students. Here if you see the denominator, it is air plus water plus solid. Here it is water plus solids. So definitely this volume will be less. Hence you can write that the saturated unit weight is always greater than the bulk unit weight. And this can be justified with the formula also. For now you just remember this, student. Now when I talk about the dry unit weight, so what do you mean by dry unit weight? When it is nothing but the bulk unit weight, when the voids are completely filled with air. So here dry unit weight gamma D can be considered as weight of solids upon total volume. Weight of solids upon total volume is nothing but gamma D. Okay. Here the volume will be equal to volume of air plus volume of solids, because here the volume of water will be 0. So you should have an idea on the volume characteristics also based on the state of the soil. Now my dear student, the next one we have is the unit weight of solids. Unit weight of solids. Now what is the formula for unit weight of solids? What will be the formula for unit weight of solids? Anyone, my dear students? So here when I talk about the unit weight of solids, gamma S will be written as weight of solids. It can be written as weight of solids upon volume of solids. Gamma S can be written as what? Weight of solids upon volume of the solids. So here if I talk about gamma S, you can write it as weight of solids upon volume of solids. So what I would like to tell you is, for a given soil, what is constant, students? I told you clearly. For a given soil always weight of solids, and you can write here for a given, soil, weight of solids and volume of solids is constant. You can write here weight of solids and volume of solids is constant. So you can definitely say that when numerator and denominator are constant, definitely you can write here gamma S as constant. Definitely you can write unit weight of solids as constant. Yes or no, students? So here we have studied about bulk unit weight, dry unit weight, and unit weight of solids, and as well as saturated unit weight. Still we have one concept, that is unit weight of water. Unit weight of water, and this value is very important, students. When I talk about the unit weight of water, gamma W is defined as weight of water. This is very important in problem solving. You should be smart. What should be the unit volume of water? I'll tell you how. Sir, weight of water upon volume of water. So here gamma W is equal to weight of water upon volume of water. So gamma W can be taken as 1 gram per centimeter cube, or this can be taken as 1 ton per meter cube. Okay, or you can write it as 9.81 kilonewton per meter cube. See, students, I will give you one simple example here. If the weight of water is increasing, then definitely volume of water will also increase. If weight of water is increasing, then definitely volume of water will also increase. Then definitely the ratio will be constant. That is the reason gamma W, it can be 1 gram per centimeter cube, or 1 ton per meter cube, or 9.81 kilonewton per meter cube. So here what I would like to tell you importantly, I have a beautiful question. If you are writing IAS exam, Amma, you will be finding very difficult in solving because you won't have the calculator. In that case, even the answer, if you see the answer in kilonewton per meter cube, suppose you have seen the answer in kilonewton per meter cube, then don't take gamma W as 9.81. Still, you can do with 1. But the final answer, whatever you get, that final answer you just multiply with 9.81, and definitely you can save your time. Sir, it is a small technique, but it will help a lot, because in IES, 3 to 4 questions will be coming from this topic, properties of soil. Now we have submerged unit weight. Next we have is the submerged unit weight. Now see, students, first of all, most of the people are aware or not, I am not sure, but when I am studying my college, I used to have a lot of queries regarding the submerged unit weight and regarding the saturated unit weight. When I talk about the saturated unit weight, my dear students, the voids are completely filled with water. But whenever I talk about submerged unit weight, it is a condition. A state of the soil is saturation, but what is submerged? It is a condition. So suppose if you have taken a beaker or a vessel, it contains full of water. And if you see here, there is a cricket ball which is made up of entire soil. Now if you consider the state of the soil, it is saturated, but the condition is submerged. So here always the self weight acts downwards, that is gamma set, and there will be a buoyancy force which is acting in the upward direction, that is gamma W. So my dear students, submerged unit weight can be written as gamma sat minus gamma W. Gamma sat minus. Okay, now see, students, we have to be very careful also. Suppose if I have taken another beaker, and here you are taking a cricket ball which is entirely made up of soil, and here you have the water. This is entire water, And now see students, when you immerse the ball, that much water will be displaced. So you might be knowing Archimedes principle. You might be knowing the Archimedes principle. So what is Archimedes principle says? Sir, Archimedes principle says that volume of the water displaced. Archimedes principle says that volume of water displaced will be equal to the volume of the body. Volume of the body means here volume of solids, and this will help you a lot. So here you can write here volume of water displaced is equal to, yes, volume of water displaced is equal to volume of water displaced is equal to volume of solids. So Archimedes, according to the Archimedes, please write this one as a note. Volume of water displaced is equal to volume of solids. Now see students, I have a small question for you. The problem is a soil of volume, 45 centimeter cube, a soil of volume 45 centimeter cube is poured in a soil of volume 45 centimeter cube is poured in a graduated cylinder, It displaces 25 centimeter cube of water. What sir? It displaces 25 centimeter cube of water. Calculate the void ratio. So my dear students, just now I have explained you. According to the Archimedes principle, the volume of the water displaced. So you can write here solution clearly. Volume of water displaced. What we can write, my dear students? Volume of the water displaced is equal to volume of water displaced is nothing but volume of water displaced is nothing but what, my dear students? Is nothing but the volume of solids. So volume of water displaced is equal to volume of solids. And here volume of water displaced is equal to 25 centimeter cube. So 25 centimeter cube is equal to volume of solids. And you know total volume is equal to 45 centimeter cube. So here, my dear students, total volume is equal to VV plus VS. So here total volume is how much, students? 45. Volume of voids is how much it is? We don't know. And volume of solids is 25. So here volume of voids will be equal to 20 centimeter cube. Now if you consider a void ratio is defined as volume of voids upon volume of solids. So volume of voids is equal to 20 centimeter cube upon volume of solids is 25. This will be equal to 0.8. So this value will be equal to, what is the value of the void ratio here? It will be equal to 0.8. If you don't know the volume of water displaced is equal to volume of solids, according to the Archimedes principle, this problem cannot be solved. I hope you are clear. Now see students, actually we have another concept called specific gravity. Here we have another concept called specific gravity. So how do you define specific gravity? Again, in specific gravity, we have two things. One is the true specific gravity and other one is the apparent specific gravity. Sir, actually, what is the apparent, or you can write mass specific gravity? Sir, what is the point of learning specific gravity is? It is very simple. If you want to convert one unit weights into the other unit weights, if you know the unit weight of water and if you know the specific gravity of any substance or any liquid or anything, definitely you can find the unit weight of that solid. Now here, if you talk about a mechanical engineering, if you want to know the battery, if they are doing a self-start, to know the condition of the battery, you should also know about the specific gravity. So here specific gravity is defined as the ratio of unit weight of solids upon unit weight of water. As I told you clearly, my dear students, when I am discussing the unit weight or when I am discussing the unit weights, you have already informed gamma S is constant, and you have informed me gamma W as also constant. When you inform gamma S and gamma W as constant, then definitely G will be also constant. Then definitely G will be also constant. And we have the mass specific gravity. This, see students, mass specific gravity is defined as GM. GM can be written as gamma upon gamma W, or it can be written as gamma D by gamma W, or it can be written as gamma sat upon gamma W. Then definitely you have a question. Sir, why it is having 3 equations? That itself says that it is not constant. So when you are talking about the bulk specific gravity, then it is in bulk state. When you are telling gamma by gamma W, it is bulk state. Gamma D by gamma W, then it is dry state. And when I am talking about gamma sat by gamma W, then it is saturated state. Okay. So here we are clear about the specific gravities. The true specific gravity is always greater than the mass specific gravity. This explanation I'll give you in the next class, that how G is greater than GM. Okay, how G is greater than GM. And also, remember my dear students, specific gravity, we have a formula which is known as picnometer method. How do you determine the specific gravity in the picnometer? In the next session, I'm going to discuss this, and also how the important formulas in properties of soil using the basic things like water content, degree of saturation, air content, unit weights, saturated unit weight. We have a important formulas, and from that formula sheet, it is my challenge for you that in GATE-24 there will be a 95% chance of getting a question. And remember students, we at IMS GATE Academy provide you the offline GATE coaching at Jayanagar, Bangalore. And if you are really interested in from Andhra Pradesh, we are also providing the offline GATE coaching at Vijayawada. So remember the centers in Bangalore, we are providing the offline GATE coaching at Jayanagar and near to Southern Circle metro station. And if you talk in Vijayawada, we are providing at the Ben Circle. And both the centers are offline. In addition to this, we are also providing the online GATE coaching, which includes recorded sessions. We have different test series also, like advanced level test, chapter level test, multiple subject test, and we will be providing you all the study material, like for every subject theory book and every exercise book. In that exercise book, we will have level 1, level 2, level 3 questions. Apart from this, we are also providing the GATE question booklet, and there can be recorded videos of the previous year GATE questions also. And remember, my dear students, the most important thing is at IMS GATE Academy, we take the student success as the utmost priority, and we have a session called My Plan session, which will be provided one-to-one to the student. So My Plan session will also help to identify the student weakness and how the weakness can be converted into strength. So at IMS GATE Academy, we brainstorm ourselves to give the best result. And tomorrow, when you want to know, that is the suspense, that is the reason I kept intentionally, how to measure the specific gravity. And in tomorrow's session, my dear students, I will be discussing the most important formulas on properties of soil. That slide will definitely give you 1 mark. That is my guarantee. I hope you have enjoyed this session. If you really enjoyed this session, please try to share this session. Thank you and all the best.